First, opening, when fabric became a life or death decision. For the first 15 seconds, I need your full attention, because what I'm about to share is one of the least understood truths of World War II. Thousands of soldiers didn't die from bullets. They died from their clothing. Men froze, drowned, or slipped into shock, not because their gear wasn't warm enough, but because the very fabric meant to protect them collapsed under pressure. In war, clothing was not comfort. It was survival equipment, and when it failed, lives were lost in silence. Welcome to Historia Prime, where forgotten innovations are brought back into the light. Today, we uncover the story of a miracle material born not from a weapons laboratory, but from a quiet British textile mill. A fabric so unusual, so brilliantly engineered, that it rewrote the rules of survival. A fabric lighter than traditional military gear, stronger under stress, and completely waterproof without a single drop of plastic, wax, or rubber. Before this fabric existed, armies learned a harsh truth. Nature kills just as efficiently as enemy fire. Rain weighed men down until they could barely march. Wind ripped warmth from their bodies faster than they could replace it. Canvas tents sagged, rubberized jackets cracked, and every climate exposed a new weakness. The jungle rotted gear from the inside out. The Arctic shattered it like glass. The desert scoured it with sand. The world itself became an enemy. As we begin this journey, remember this idea. When everything else fails, when firepower, strategy, and technology cannot save you, the only barrier between you and the deadly elements is the material wrapped around your skin. And in the chaos of World War II, one fabric rose above them all. A fabric that changed survival itself. Second, the failure of traditional waterproofing. To understand why this miracle cloth mattered, we must confront the brutal reality of the materials soldiers relied on before it appeared. For generations, armies used canvas treated with oils or waxes. It was familiar, it was cheap, and it was disastrously unreliable. Within weeks in humid climates, the waterproofing washed away. Worse still, when canvas absorbed water, its weight increased by 30 to 50%, turning a soldier's uniform or shelter into a dripping anchor that drained strength with every step. Rubberized fabrics, invented with great optimism in the early 20th century, promised a modern solution. But in practice, they failed even faster. In warm weather, they softened and tore. In the cold, they stiffened into rigid plates that restricted movement and cracked under stress. A soldier's waterproof jacket could literally shatter in a blizzard. What was meant to shield men from the elements instead made them slower, colder, and more vulnerable. And the battlefield punished these weaknesses brutally. In the Pacific, constant moisture caused mold that ate through fabric like acid. Packs rotted, uniforms weakened, medical kits mildewed. In Arctic regions, temperatures turned rubber coatings brittle until they flaked apart in sharp, useless shards. A garment that protected a soldier 1 hour could fail catastrophically the next. This is why engineers came to a stark conclusion. A waterproof system that fails suddenly is more dangerous than no system at all. When a material collapses without warning, the soldier has no time to adapt, no chance to save himself. It became clear that old methods could not be patched, improved, or optimized. They had reached their limit. If soldiers were to survive the unforgiving environments of World War II, the world needed a new kind of fabric, one that did not rely on coatings, chemicals, or fragile layers. Something fundamentally different. Third, the deadly clock. Immersion survival reality. No battlefield exposed the failure of old materials more brutally than the North Atlantic. RAF pilots who crashed into the ocean entered water temperatures between 0 and 5 degrees Celsius. In these conditions, the human body begins a rapid countdown the moment it is submerged. Within 3 to 5 minutes, a pilot loses fine motor control, muscles stiffen, fingers stop responding, and even simple movements become impossible. By 10 to 15 minutes, most lose consciousness. Traditional flight suits offered almost no protection. They absorbed water instantly, becoming heavy and rigid. Instead of keeping pilots afloat, they pulled them downward. The cold water did not need to drag them under. Their own gear did it for them. Medical officers documented case after case of pilots who were strong swimmers in peak physical condition, yet paralyzed by cold long before help could arrive. The RAF conducted extensive survival testing and reached a chilling conclusion. The key was not insulation, It was water absorption. Any material that soaked up water, even the smallest amount, accelerated heat loss and increased drowning risk. To save lives, the new fabric needed to do more than resist water. It needed to remain light, flexible, and buoyant, even in freezing seas. This realization changed everything. Engineers now understood that the goal was not simply waterproofing, as the world had defined it for centuries. The real requirement was preventing water from entering the fabric at all. A material that would not swell, would not sag, and would not turn into a death trap the moment it touched the ocean. The search for such a fabric seemed impossible, and yet in one of the most unexpected turns of World War II engineering, the solution would come from the most ordinary fiber imaginable: cotton. 4. The counterintuitive solution. Why cotton? 1. What came next was one of the most surprising turns in wartime engineering. While military research teams around the world chased synthetic polymers, rubber blends, barbonens, and chemical coatings, British textile engineers in Manchester went the opposite direction. They looked not toward modern chemistry, but toward the oldest fiber humanity has ever woven: cotton. At first glance, it seemed absurd. Cotton absorbs water, cotton becomes heavy, cotton is the last thing anyone associates with survival in the freezing Atlantic. And yet, this weakness, this tendency to react dramatically to moisture, became the key to a revolutionary solution. These engineers understood something deeper than the military's standard approach. Instead of inventing a material that resisted nature, they sought to harness a natural behavior already present in the world. Long staple Egyptian cotton, one of the strongest and most responsive cotton fibers ever grown, swells significantly when it absorbs even a small amount of moisture. Unlike short fibers, which deform inconsistently, Egyptian cotton expands evenly and predictably. This trait, once seen as a liability, became the foundation of a breakthrough. The engineers wove this cotton so densely, 300 to 400 threads per inch, that the fabric behaved differently from anything previously made. When dry, it felt soft and breathable, almost delicate. But when a single drop of water touched it, the fibers expanded microscopically, tightening the weave. Not with chemicals, not with coatings, but with physics. The tighter the fibers locked together, the more the fabric sealed itself, creating a barrier that water could not pass through. This was not waterproofing as the world understood it. This was structure-based defense. Ventile was born not from a laboratory filled with solvents and powders, but from the simple idea that nature, if properly understood, could defend itself. The result was a fabric that flipped every assumption upside down. Cotton, the material known for soaking up water, became the material that kept it out. 5. The science. How Ventile locks out water. To grasp why Ventile became legendary, we need to look closely at how it behaves under real conditions. When the fabric is dry, it feels almost unremarkable, light, flexible, and quietly breathable. Air passes through it just enough to keep the wearer comfortable. It does not crinkle or rustle. It does not stiffen in cold air. To a soldier, this meant freedom of movement, warmth without overheating, and the rare gift of silence in a world where noise could mean death. But everything changes the moment moisture arrives. When rain, snow, or seawater hits Ventile, each cotton fiber begins to swell outward across its diameter. Because the weave is already so dense, even a small amount of expansion causes the microscopic gaps between fibers to collapse. The fabric doesn't become coated in water, it becomes structurally closed to water. Instead of depending on a fragile surface layer, Ventile transforms from the inside out. Its behavior is not reactive, it is adaptive. This stands in stark contrast to traditional waterproofing. A coated fabric protects only as long as its outer layer remains intact. Once that surface wears down, cracks, or rubs off something guaranteed in combat, the material instantly fails. Ventile, by contrast, has no layer to lose. Its waterproofing is not a film. It is the fabric itself. This is the heart of its brilliance. Ventile does not repel water. It removes water's pathway. Even under high pressure, droplets cannot find a gap to enter. Yet, because the fibers swell only when wet, the fabric remains breathable in dry conditions. This dual-state performance is something even modern synthetics struggle to replicate. Ventile reacts to its environment like a living material, changing form when threatened and relaxing once the danger passes. In a war defined by extremes drenching rain, ocean storms, melting snowfields, this behavior saved lives. Ventile was engineered not to dominate nature, but to cooperate with it. And that choice made all the difference. Sixth, lighter, weight comparison. Under real conditions, one of the most overlooked advantages of Ventile is its behavior under real battlefield stress. A fabric's weight on paper means almost nothing when compared to its weight after absorbing water. Canvas, the military standard for decades, becomes dramatically heavier the moment it gets wet. In field tests and combat experience alike, soaked canvas often increased to 1.5 or even 2 times its dry weight. For soldiers marching through mud, climbing out of trenches, or struggling in open water, this extra weight translated directly into lost energy, slower movement, and higher risk of exhaustion or hypothermia. Ventile, however, behaves entirely differently. Because the fibers swell to close the weave rather than absorb large volumes of water, the fabric's overall water uptake stays remarkably low. Instead of becoming a sponge, it becomes a barrier. A Ventile jacket remains close to its original weight, even in heavy rain. For ground troops, this meant fewer calories burned and more endurance over long marches. For commandos operating in cold environments, it meant less conductive heat loss. And for RAF pilots fighting to stay afloat in freezing seas, the reduced water weight meant precious seconds of buoyancy and stability. This difference is not merely technical, it is physiological. The human body loses heat far more quickly when weighed down by wet, clinging fabric. By remaining light, Ventile slowed the rate of heat loss and gave rescuers a critical margin of time. And in survival, a margin of time is everything. This is why the phrase becomes so powerful. Ventile wasn't light on paper. It was light when it mattered. It stayed light in the storm, in the waves, and in the kind of desperate moments where every gram of unnecessary weight pushes a life closer to the edge. In the unforgiving environments of World War II, that difference didn't just improve performance, it saved lives. 7. Stronger, durability over time, not just force. When we think of strength in clothing, we often imagine a single moment, a fabric resisting a tear or withstanding a sudden strain. But in survival, true strength is measured over seasons, over years, and under conditions that slowly, relentlessly erode everything. And this is where traditional materials failed long before the battle ever reached them. Canvas, the long-trusted workhorse of armies, tears easily along its weave. Once a single thread gives way, the rip continues like a zipper undone by force. Worse yet, canvas ages quickly. Sun, salt, moisture, and friction weaken its fibers until the material becomes fragile without any visible warning. A jacket or tent that seemed sturdy one month could disintegrate the next. Rubberized cloth suffered a different fate. It didn't tear easily, but it decayed in silence. Cold temperatures caused the rubber to stiffen and crack. Heat caused it to soften and peel. And once the rubber layer was compromised, the entire garment failed instantly. A single crease could start a fracture. A few months of field use could reduce a coat to fragments. Soldiers learned quickly that rubber gear was strong only in theory, not in the brutal reality of war. Ventile, however, followed a different philosophy. Because it relied on extraordinarily dense weaving instead of coatings, its integrity didn't depend on a fragile outer layer. Even if the fabric was scraped, abraded, or partially torn, the weave prevented damage from spreading. A small puncture remained small. A cut refused to widen. The structure itself absorbed stress instead of unraveling. This made Ventile not just strong in a moment of force, but strong across long campaigns, harsh climates, and repeated use. It did not rot, it did not peel, it did not become brittle, and it did not suddenly abandon the soldier wearing it. Strength in survival gear is measured in years, not moments. And by that standard, Ventile did more than outperform its rivals. It outlived them. 8. Totally waterproof, a controlled definition. At this point, it would be easy to exaggerate Ventile's abilities and claim that it was completely waterproof in every situation. But honesty, especially in survival engineering, matters more than praise. Ventile was not designed to keep a soldier perfectly dry for infinite hours. It was not meant to function as a rubber diving suit or a sealed modern membrane. What Ventile did brilliantly and consistently was seal out water during the moments when survival depended on it. In heavy rain, the fabric swelled into a nearly impenetrable shield. In snow, it prevented melting flakes from soaking through. And in the violent churn of cold seawater, Ventile bought its wearer crucial minutes, minutes that determined whether a pilot lived long enough to be found or slipped beneath the surface unseen. This distinction matters. Ventile's power lay not in permanent dryness, but in controlled, predictable resistance. Unlike coatings, which wore out, rubbed off, or cracked, Ventile required no maintenance. It did not need waxing, retreating, or chemical repair. It simply worked every time nature threatened and relaxed when conditions eased. This makes its legacy even more impressive. The engineers who designed Ventile did not chase perfection, they chased survival. They understood that a fabric could not outlast the ocean or outfight a storm, but it could be engineered to give a human being a fighting chance, a window of time where rescue became possible. Ventile was designed to buy time, not comfort, and in the unforgiving environments of World War II, time was the rarest and most valuable resource a soldier could have. 9. War-proven evidence, RAF and field adoption. A fabric can sound extraordinary in theory, but in war only results matter. Ventile earned its reputation in the harshest proving ground imaginable, the freezing waters of the North Atlantic. RAF survival tests revealed that suits made from Ventile extended pilot survival time by 15 to 20 minutes, an eternity, in waters capable of killing within 10. This was not a marginal improvement, it was a transformation. Families received sons and husbands back alive because Ventile kept them warm and afloat just long enough for rescue crews to arrive. But the battlefield tested more than seawater. In Arctic campaigns, where temperatures shattered traditional gear, Ventile remained supple. It did not stiffen, it did not split. Soldiers could move freely without fighting against their own equipment. For units operating in sub-zero blizzards, this reliability meant maintaining mobility, accuracy, and stamina, 3 factors essential to staying alive. In the jungles, where moisture devours equipment with mold and rot, Ventile proved almost immune. Commandos discovered that the fabric resisted deterioration far better than canvas or rubberized cloth. Packs, jackets, and ponchos lasted longer, smelled cleaner, and failed less often. In tropical warfare, where disease and decay killed more soldiers than bullets, longevity was a strategic advantage. Perhaps the most impressive demonstration came from multi-role field gear. Ventile ponchos could act as shelter, ground sheet, or emergency stretcher. A single piece of cloth served 3 critical functions without tearing, leaking, or collapsing under weight. Gear that stayed intact meant missions that stayed alive. Ventile was not chosen because it looked good on paper. It was chosen because it saved lives in the ocean, in the jungle, in deserts, and in the Arctic. In every environment where other fabrics failed, Ventile endured. That is why its legacy continues to this day, long after the war that first demanded its creation. 10. Why it disappeared. The scaling problem. For all its brilliance, Ventile carried a flaw that had nothing to do with performance and everything to do with production. The very qualities that made it extraordinary on the battlefield made it extraordinarily difficult to manufacture. To achieve the dense weave of 300 to 400 threads per inch, mills needed long staple Egyptian cotton, one of the most expensive and carefully cultivated fibers in the world. Only a handful of farms produced cotton of this grade, and only specialized looms could handle such demanding precision. Each meter of Ventile took far longer to weave than ordinary cloth, and defects couldn't be tolerated because even a tiny inconsistency in the weave compromised its waterproofing behavior. During the war, governments were willing to pay the price. Lives were at stake, and survival always costs more than convenience. But when the fighting stopped and the world turned toward rebuilding, economics, not engineering, began to dictate what fabrics succeeded. Nylon exploded onto the market. It was cheap, it was fast to produce. It didn't require rare cotton crops or meticulous quality control. Even though nylon didn't breathe as well, didn't age as gracefully, and didn't handle flame or cold with the same reliability, it won for a simple reason. It scaled. Factories could produce mountains of nylon in the time it took to weave a small batch of Ventile. Militaries, eager to cut budgets, accepted the trade-off. Industries followed, and the miracle fabric slowly slipped out of mainstream use, not because it failed, but because it could not compete with speed and volume. This is the essential truth. Ventile didn't disappear because it failed. It disappeared because it couldn't be rushed. In a world shifting toward mass production, craftsmanship lost to convenience. And yet, even as Ventile faded from common uniforms, explorers, survivalists, and specialists kept it alive. They knew its worth, they knew its legacy, and they knew that some materials are too valuable to abandon, even if industry moves on without them. 11. Recreating the logic, not the fabric today, Ventile remains rare, but the lessons behind it are more relevant than ever. In an age of disposable gear and synthetic membranes, survivalists and craftsmen have begun rediscovering the old principle hidden inside this miracle cloth. Don't copy the fabric, copy the thinking. The power of Ventile came from structure, not chemicals. From understanding how a material behaves, not forcing it to act against its nature. Modern recreations follow the same philosophy. Start with tightly woven cotton or linen, not as dense as true Ventile, but tight enough to control airflow. Treat it not with synthetic sprays, but with boiled linseed oil, or a blend of linseed oil and beeswax, warmed until it flows deep into the fibers. These natural finishes stiffen slightly as they cure, strengthening the fabric without sealing it in plastic. The material remains breathable, flexible, and repairable. And because the treatment is thin and structural rather than layered and thick, it fails slowly, giving the user time to react rather than collapsing without warning. The principles remain timeless. Structure matters more than surface. Internal behavior matters more than external appearance. And in survival gear, slow failure is far safer than sudden failure. This mindset is what modern gear often forgets. It prioritizes waterproofness today over durability tomorrow. But the logic of Ventile offers a more resilient approach. Engineer a fabric that works with nature's forces, not against them. By recreating the philosophy, not the exact weave, we gain something powerful, a return to materials that breathe, protect, and endure. Materials that can be made by hand when supply chains break. Materials that remain useful even when scratched, weathered, or aged. This is the survival wisdom hidden inside Ventile's design, waiting for modern hands to rediscover. 12th, conclusion. When materials are allowed to work, as we reach the end of this journey, one truth rises above all the details, tests, and battlefield stories. Ventile was never advanced because it relied on cutting-edge chemistry. It was advanced because it relied on understanding. It proved that nature, when read correctly, can produce solutions stronger, lighter, and more adaptable than the synthetic shortcuts we often chase today. Ventile is a reminder that technology isn't only about inventing new substances. It's about listening to the materials we already have. Cotton isn't miraculous by itself, but when woven with intention, with patience, and with respect for how its fibers expand and contract, it becomes something more, a shield, a lifeline, a companion in the harshest environments a soldier can face. This fabric stands as a quiet rebuke to modern design. We seek coatings instead of structure, convenience instead of durability, instant waterproofing instead of resilience earned by craftsmanship. But Ventile teaches a different lesson. It shows us that the best survival gear doesn't overpower nature. It collaborates with it. Modern gear fights nature, Ventile survived by cooperating with it. And in that cooperation lies a philosophy we would do well to remember, whether we are exploring the wilderness, preparing for uncertainty, or simply learning from the ingenuity of those who came before us.